out of our little talk that we're having, a little online discussion that we're having on time travel. I'm watching a few videos on the subject. Right,
ingredients of life.
we've got one here. Is time travel possible?
Birth in the big.
Let's watch this, see what he's got, see what the other...
I'm Mary, and on this farm, everything we do is to make Ginster's pasties even tastier. Apparently music helps. Ginster's tasty effort.
On Booking.com, it's easy to go from home to holiday home.
Ingredients of life itself. Hydrogen is in our bodies. That was birthed in the Big Bang. And then we have carbon, nitrogen, oxygen, silicon, iron. Those elements did not come from the Big Bang. They came from stars. It's not just figuratively true. It's literally true that we are stardust. Hi, I'm Neil deGrasse Tyson, your personal astrophysicist, and I'm here to answer questions from the Honesty Box. Here we go. First question. Could a comet or asteroid destroy Earth? A comet or asteroid will take out life on Earth, but Earth itself will be just fine. So when people say, especially people in the green movement, we need to save Earth, save planet Earth, you have no idea how resilient planet Earth is. It got slammed by a Mars-sized protoplanet, made the moon, and Earth is still here. What you really mean is, well, can it destroy life on Earth? It's done it before. It'll do it again, unless we figure out a way to deflect the asteroids. I don't want to be the laughing stock of the galaxy. To be the only species that went extinct from an asteroid, yet we also had a space program. That's just embarrassing. Like, no. Do aliens exist? Don't know. We're looking for them. What I'm pretty sure is that they have yet to visit Earth. Because if they did, it would be odd that they only visit U.S. government facilities. Okay, so maybe they do exist and they have visited, but they are inherently fuzzy. And they target restricted naval airspace, but only of the U.S. government. Prove the Earth is not flat. Prove it? Prove the Earth is not flat. Okay. Do you have tall buildings where you are? If you do, and a sight line to the horizon, positions people from the ground floor up to the top floor and have someone hanging out in the roof. And all you have to do is, at a sunset, when you have a clear view to the western horizon, have each person looking out the window, when they see the sun set below the horizon, have them raise their hand or shout out. And you'll see one by one, in sequence, each person raise their hand until the person does so from the roof. That tells you that the sun is disappearing behind a curved surface. And if Earth were flat, when the sun set below that edge, everyone would raise their hands simultaneously. Or you could look at photos from NASA. What's something about the universe that makes you emotional? All of it. But especially the fact that the ingredients of life itself, hydrogen is in our bodies. That was birthed in the Big Bang. And then we have carbon, nitrogen, oxygen, silicon, iron. Those elements did not come from the Big Bang. They came from stars, forged in their core from thermonuclear fusion. And those stars happen to be the stars that also explode, scattering that enrichment across the galaxy, allowing subsequent generations of stars to have planets some of which have the right ingredients for life. What is biology but highly complex chemistry? And there's no understanding of chemistry without physics. So all of this comes together. And so these ingredients that comprise us were birthed in stars. It's not just figuratively true, it's literally true that we are stardust. We are alive in the universe, and the universe is alive within us. That is a gift from 20th century astrophysics to modern civilization that borders on the spiritual. That makes me emotional. How many molecules are there in a glass of water? Ooh, there's bajillions in a glass of water. All I will tell you is that there are more molecules in a glass of water than there are glasses of water in all the world's oceans. Think about that. When you drink that glass of water and those molecules come out of your body in any one of a half dozen ways, those water molecules go back into the environment. There's enough water molecules that came back out of your body to scatter into every other glass that anyone draws from the world's water supply. Given enough time, it gets completely mixed. That means every glass of water you drink, there are molecules that pass through the kidneys of King Henry VIII, Winston Churchill. And pick your favorite historical character. So you want to talk about the oneness of all life on Earth? The water molecules through your system captures that fact. Why was Pluto demoted? It had it coming. I mean, come on. Most people who are Pluto lovers don't know the following facts. Ready? Okay. A, more than half of Pluto's volume is ice. If Pluto were where Earth is right now, it would grow a tail because heat from the sun would evaporate that ice. It would have a tail. That's no kind of behavior for a planet. Not only that, Pluto's orbit crosses the orbit of another planet. No other planet does that. You know what does do that? Comets. You know, comets are made of ice. Pluto is not necessarily the biggest thing in its orbit. There are other objects that rival Pluto in size. It does not own its orbital space. In fact, we concluded Pluto was one of the larger objects of a new swath of real estate discovered in the universe called the Kuiper Belt of icy bodies, the Kuiper Belt of comets. So yeah, Pluto's happier there because it's like the king of the comets instead of the puniest planet. Is intelligent life an evolutionary fluke or an inevitability? Ooh, well, a couple of things. How inevitable can intelligence be if we're the only intelligent life on Earth, and Earth has been around for 4.8 billion years? If it were inevitable, you'd think it would show up more frequently in the tree of life, but it hasn't. So it's not clear how inevitable it is. If aliens came to visit looking for intelligent life, and they arrived 500,000 years ago, that's tiny compared with the history of the Earth. We're not here yet, and they wouldn't find any intelligent life. So it's not clear how inevitable it is. What you don't want, what could likely happen, especially lately, is aliens come to Earth, and they go home and report back, there's no sign of intelligent life on Earth. When will the universe end? Not in fire, but in ice. And not with a bang, but with a whimper. We are on a one-way expansion trip. Never to cease, never to slow. And if dark energy has its way with us, in 10 to the 22 years, the expansion of the universe would have accelerated so rapidly that it would have ripped the very fabric of space and time itself. We call that the Big Rip. I don't even want to know what that looks like. What happens when we die? I can answer, if you're religious, you go to heaven and you hang out with all your relatives. I can answer this as a physicist. We are warm-blooded creatures, which means my skin temperature is nearly 100 degrees Fahrenheit. And the room I'm in is not. The room I'm in is 70 degrees Fahrenheit. Okay? So in Celsius, body temperature is like 37, but room temperature for you is like 20, 23 degrees. So you are maintaining a temperature difference every waking moment of your life. If you died, your body would cool to air temperature. That's why if you've ever touched a corpse in a casket, the first thing you know is, oh, it feels cold. No, it's actually air temperature. It feels cold compared to when you normally touch a human body. All right, why does the body temperature drop? Because you're no longer metabolizing energy. The only reason why we consume food, other than the nourishment, is to have energy to maintain this body temperature difference. Okay. Also, we have neurosynaptic activities in our brain. Our thoughts, our consciousness. Let's say you die by a series of mini strokes. You know the person to whom this is happening. And bit by bit, their personality goes away. They lose their ability to recognize you. They don't know how to speak. They don't know where they are. Their consciousness fades, and you're witness to this. If you do a scan of their brain, you'll see parts of the brain shutting off because they're not activated by oxygen. That's what strokes do, of course. Then the person dies, and the metabolism stops. You put them in the earth, the molecules still contain energy. And those molecules are dined upon by microorganisms in the earth. And you are given back to the ecosystem. You're given back to the circle of life. I choose to be buried for that reason. I spent my whole life dining upon flora and fauna. It's about time I gave back to them in death. So, when we die, I'm not given reason to think that your state of mind in death is any different from your state of mind before you were born. Before you were born, you say, where am I? How come I'm not? No, it's a state of non-existence. After you die, state of non-existence.
Cheerios.
Oh, pesky adverts again.
High fibre from oats, wheat and barley. That's a little win. Cheerios, little O's make little wins. And try the new Very Berry Cheerios. Enjoy the taste of berries in every bite.
This many bowls won't ensure that your cat stays hydrated. Discover Purina One Hydrolife and help support their daily hydration with a taste they'll enjoy. Purina One Hydrolife. Make it easy.
I didn't actually know.
Palladium Hotel Group, we're made for this. And all of this, we're made for memories.
Getting on the filming team, it's where the instructor becomes a global fitness icon.
Trade pay has been a real game changer for us.
So, that's what science says about death. But death is so scary to so many people. We fear death because we're born knowing only life. Is teleportation possible? What you'd have to do, you have to be like demolecularized, turn into a beam of energy, and they beam the energy to another location, retaining all the information that is you. Because you kind of lose that information when you convert matter into energy. But you have to somehow retain it and then reassemble your atoms. I'm waiting for the future where we invent wormholes. Then you just step through to the destination. No dematerializing, no reassembling. your atoms and putting back the information of all your neurosynapses that makes you in your mind, you just step through the wormhole and you arrive. So teleportation, yeah, I don't think it'll ever happen for the information problem that it poses. Or just warp drive to get to where you're going. Just warp space. You know how warp drives work? I'm here and I want to get there, and that takes a long time. So you curve space, and then you jump through that short distance, and then you uncurve it. That's how you can get across the galaxy during the TV commercials. Is there life on Mars? We're looking. It wouldn't be on the surface. There's a high ultraviolet flux from the sun, protected here on Earth by our ozone. No such protection on Mars. Ultraviolet is hazardous to biology. If there's life on Mars, maybe it's in the waters that are beneath the surface, in like an aquifer, something such as that. How does the Earth spin? Everything spins. Everything. Particles, planets, stars, galaxies, everything. When they form from larger gas clouds in the universe. If the gas cloud has any motion at all sideways, no matter how small, as it collapses, that motion grows. It's called the conservation of angular momentum. We all know this. We've all seen it. We've seen it with ice skaters, where they come to make a spin, and their arms are outstretched. And as they bring in their arms, what happens? They spin faster and faster and faster. And they can take their arms and put it up above their heads so that their arms get even closer to the axis of rotation, and they spin really, really fast. If you want to reverse that, then you just extend your arms back again. So that ending posture, that ending panache at the end of the spin, they have to do that. Otherwise, they keep spinning. So when you see an ice skater do that, just keep that in mind. Everything spins. And when it spins, something has to stop it. And it'll spin forever, basically. Okay. Or when you spin a top or anything there's friction between it and the surface. So it eventually slows down. In space, there's no friction.
Hiya.
So we good. Who is the GOAT of science? Greatest of all time, Isaac Newton. Duh. He's your boy, Isaac Newton.
Hiya.
Buried in Westminster Abbey.
Hi.
He discovered
Hello.
the laws of optics, the laws of gravity. Single-handedly invented integral and differential calculus, practically on a dare. Because someone said, Ike, why do the planets orbit in ellipses rather than perfect circles? I don't know. I'll get back to you. And then he figures out why. And his friend says, well, how did you figure this out? Well, I had to invent calculus to answer that. Well, he did all that by the time he turned 26. And by all evidence, in case you're wondering whether you will ever achieve this yourself, by all evidence, he died a virgin. These things come with costs. Isaac Newton, no doubt it. Is time travel possible? We are already time traveling into the future, 1 second at a time. The problem, though, is we are prisoners of our own present, forever transitioning between our inaccessible past and our unknowable future. So you will always age at 1 second per second. The question is, what is the rate that you are aging compared to places around you? Because not everyone experiences the same timeline. Not everyone experiences the same rate of progress of time. If you're in a strong gravitational field, time ticks more slowly for you. If you travel fast, time ticks more slowly for you, relative to others looking on. So that's all we've got. However, if you can make a wormhole, there's a way to time travel through the wormhole. But we don't have wormholes yet. Stephen Hawking suggested if you go back in time to your own timeline, you might accidentally disrupt your timeline, prevent your parents from meeting, and then you're never born, so that you don't exist to go back and disrupt your own timeline. So that's a paradox. So Stephen Hawking said we can't have these paradoxes. So maybe one day we will discover something he called a time travel conjecture, which prevents us from traveling in time, just to avoid that very outcome. So, a favorite subject of science fiction writers, by the way. And best among them, best. Now, at Doctor Who, they do okay. There's some fun time travel things going on there. But I would say in terms of movies, definitely Back to the Future. Check it out. Are UFOs real? If you see something in the sky and you don't know what it is, it's real. It's a real UFO because the U stands for unidentified.
Right, I'll stop it at that point. So someone asked Neil deGrasse Tyson, or deGrasse Tyson, or whatever his name is, about the possibility of time travel, and he answered the question as best he could. But does anybody else have any opinions on this subject, on this topic, they'd like to share with us? Does anybody else see time travel as being a possibility for mankind? They reckon if you could travel at speeds close to the speed of light, you would travel through time because when you're going at that sort of speed, you're overtaking everybody else. You've exceeded the speed limit as far as time goes because of the speed that you're going at. It's a concept known as time dilation. Well, we'll watch a video on time dilation. Time dilation explained. Right, let's watch more Neil deGrasse.
They say
Or Neil
Amazon
deGrasse,
was
whatever his
okay.
name is.
Well, it could have been if they'd used Amazon Business. Discounted bulk orders on your business supplies. Guides on what to buy. Bravo. And analytics so you know where all the money's going. Oh, careful. Now that deserves a day off. Amazon Business, your partner for smart business buying.
I still lose sleep over this fact. Okay, I still lose sleep over it. And I want you to lose sleep too. I don't want to be the only one staring at the ceiling at night.
I'm going to tell you, a lot of things already beat you to that.
Oh, sure. I mean, the asteroid strike that could happen, or the,
Exactly.
or the global warming, or... All right. So here it is. You may remember, or you may have heard, that Einstein's relativity,
Right.
more specifically, you learn this in special theory of relativity, where the faster you move,
Right.
the slower time ticks for you
Right.
as others view it.
Relative to the observer.
Relative to the observer, correct. You don't know anything's happening.
Right.
Your clock still ticks as far, you still got your heartbeat, all of this. Okay, so this is not a physiological thing. There's an actual property of the fabric of space and time under those conditions.
Wow.
Okay?
That is fascinating.
It's completely fascinating. It's completely. So I watch you fly by, and the faster you go, the slower time ticks for you. Okay?
But my time stays the same.
To you.
To me. Right.
To you. So not only does speed do this, also the strength of a gravitational field will have the same effect on you.
Oh.
The stronger the gravitational field is, the slower time ticks for you.
Oh.
And that wasn't formulated until his general theory of relativity 10 years later. That took a lot more math and deeper insights into the universe.
Well, once again, it makes sense because you're dealing with the fabric of space-time.
It's the fabric of space-time, correct.
Wow. Okay.
But initially, when formulated, you're thinking it's just because you're moving.
Right.
But it's actually way deeper than that. And that's why that one, oh, by the way, his original special theory of relativity was not called that. The title of the research paper was On the Electrodynamics of Moving Bodies.
What?
Okay, that was the title. We would later call it the special theory of relativity because it was a special case of what would later then be called the general theory of relativity. While we're there, and just slip this in, the GPS satellites orbit higher than like the space station and other things that are what we call low Earth orbit. They're in like MEO, middle Earth orbit. There's Leo, Meo, and Geo. Okay, if you have a kid, maybe you name him that.
Yes, Leo, Meo, and Geo.
Low Earth orbit, middle Earth orbit, and geosynchronous geo orbit. Okay, so the geosynchronous satellites are like middle orbit. That is far enough away from Earth's source of gravity for them to have a measurably different space-time condition. So that their clocks tick faster than our clocks on Earth's surface. Because they're farther away. And so, remember I said the more intense the gravitational field is, the slower time ticks. So they're farther away. Their time ticks faster relative to us.
Wow.
But we get precise timings from geosynchronous satellites. So how does this work? We pre-correct the time signal from the GPS satellites to compensate for Einstein's general theory of relativity so that by the time the time reaches us, it's been properly corrected and it matters to us and our space-time continuum, not the one that's at middle Earth orbit.
Oh my goodness.
So GPS couldn't work as accurately as it does.
However, wait a minute.
What?
I'm sorry, just for me. You would have to have a standard in order to pre-correct something.
You know the rate at which its time is speeding up because you can calculate what the gravitational field is up there.
There you go. There you go. Okay.
And once you calculate that, then you do and you say, oh my gosh, the formula works. Einstein was right. Right. This is not just something on a high theory, hypothesized that may or may not be true. It is true.
I just want to be there when that phrase is uttered. Oh my God, Einstein was right.
Yeah, these aren't just cult heroes that we wish they were right.
Right.
These are real. This is real. Okay, this is the real universe we're talking about. Okay, so now watch. Let's keep going faster and faster. Let's go half the speed of light, 3/4 the speed, 90% the speed of light, 99% the speed of light. Mm-hmm. Time is ticking slower and slower and slower. For you will watch the whole future history of the universe unfold in front of your eyes. As fractions of a second go by for you. As you go 99, there's a formula for this, of course, but 99, 99.9, 99.99% the speed of light.
Because you're the observer of that. But for you, your time has slowed to the point where as you observe the things that are not moving at the speed of light, you see them
speeding up. Correct.
You see speeding them unfold.
Correct.
Boom. God, correct. That is insane.
Okay. So now watch.
Oh my God. Wait.
Now watch. Okay.
Wow.
So, I didn't even get to the part where I lose sleep.
Okay.
That's what happens. By the way, there are particles that decay. You've heard of like radioactivity, right?
Yes.
It's one part that decays and becomes another part and releases the often deadly energy.
Yes.
Okay, radioactivity. All right. Some particles. Let's take, for example, the proton.
I think this is a bit complicated. I'll watch another one. Watch this one here.
I still lose sleep over this fact. You may remember, or you may have heard, that Einstein's relativity, where the faster you move, right, the slower time ticks for you as others view it.
Relative to the observer.
Relative to the observer. Correct. You don't know anything's happening.
Right.
Your clock still ticks as far, you still got your heartbeat, all of this. Okay? So this is not a physiological thing. It's an actual property of the fabric of space and time under those conditions.
Wow.
Fly by, and the faster you go, the slower time ticks for you. Okay?
But my time stays the same.
To you.
To me. Right.
To you. So not only does speed do this, also the strength of a gravitational field will have the same effect on you. The stronger the gravitational field is, the slower time ticks for you. And that wasn't formulated until it was general theory of relativity. While we're there, let me just slip this in. The GPS satellites orbit higher than like the space station and other things that are what we call low Earth orbit. They're in like MEO. That is far enough away from Earth's source of gravity for them to have a measurably different space-time condition. So that their clocks tick faster than our clocks on Earth's surface. Because they're farther away. And so, remember I said the more intense the gravitational field is, the slower time ticks. So they're farther away. Their time ticks faster relative to us. But we get precise timings from geosynchronous satellites. We pre-correct the time signal from the GPS satellites to compensate for Einstein's general theory of relativity so that by the time the time reaches us, it's been properly corrected and it matters to us and our space-time continuum, not the one that's in Middle Earth orbit.
Oh my goodness.
Let's keep going faster and faster. Let's go half the speed of light, 3/4 the speed, 90% the speed of light, 99% the speed of light. Time is ticking slower and slower and slower. For you, you will watch the whole future history of the universe unfold in front of your eyes. As fractions of a second go by for you. As you go 99, there's a formula for this, of course, but 99, 99.9, 99.99% the speed of light.
Because you're the observer of that. But for you, your time has slowed to the point where as you observe the things that are not moving at the speed of light, you see them
speeding up.
Basically, you see them unfold.
Correct.
Boom. God.
Correct.
That is insane.
Okay. I didn't even get to the part where I lose sleep. There are particles that decay. You've heard of like radioactivity, right?
Yes.
It's one part, it decays and becomes another part and releases often deadly energy.
Yes.
Okay, radioactivity. All right. What happens if you take that particle and speed it up in a particle accelerator? So you take a community of these particles, speed them up, calculate, wait a minute, the internal wristwatch on these clocks says they should live longer. And sure enough, their decay time takes longer.
Oh my God.
Yes. Yes.
Oh, wow.
Yes.
And that becomes living proof of what Einstein said.
Yes, because we can't go half the speed of light.
Right.
But you can accelerate a particle to do that.
Yes.
It's an internal built-in clock that decays after a certain amount of time, and there they are taking longer to decay in the exact amount that Einstein predicted.
That is genius.
So we don't make this stuff up, okay? Yes, it is genius. It's like triple genius. All right, let's take this to an extreme level.
Right.
Let's go so fast that we're going the speed of light itself. Right? Well, we can't do that because we're made of material substance, and there's no way to do that. But there are things that travel at the speed of light. And what is that?
Those would be photons.
Yes. What travels at the speed of light? Light does.
Yeah.
Okay?
I was about to say light.
So, if photons had a clock, the clock would never tick.
Nice.
Which means when I go to a mountaintop, as I did in graduate school, to observe the center of the Milky Way galaxy for stars that emitted their light 30,000 years ago, traveling through the gaps of interstellar space, and they move through space, come through Earth's atmosphere, they come down into the telescope, they reflect, go back to my detector, and land on my CCD chip. That photon, when it was born,
at the star that emitted it was detected at my telescope in the same instant.
Wow.
According to the photon itself.
Live fast, die hard.
The photon has no knowledge of that trick.
Right.
Because time did not exist for it. Pasta Pringles.
The all-new 10 for £100 from Hotels.com is exactly what it sounds like. Stay 10.
One of the most intriguing questions we've all wondered about when we were kids is whether we can travel into the future or go back in time using some sort of time machine. The question still remains intriguing even in our adult lives. Unfortunately for us, science has advanced to the point where we can answer this age-old question.
We can easily travel forward in time, and we've known how to do that since 1905. Einstein's special theory of relativity lays out the whole recipe of how you can move into the future. And all you have to do is go into sort of a lower gravity field relative to other people, or just travel very fast. And your clock will tick slower than that of everybody else that you've left behind. And then when you return, you'll be younger than your twin, for example, if you had left your twin back on Earth. So in that sense, you are traveling into the future. That's easy to do, and we've known how to do that. Traveling backwards, that's the problem. We think we can do that. I have some colleagues who've made some calculations that assert that depending on a trajectory you take around a black hole, you come out and end up in the past of when you started. But that takes extraordinary setup to make happen. But right now, no problem traveling into the future.
We've known the answer that it is absolutely possible to travel forwards in time. In fact, we have irrefutable evidence to show that. So before we dwell into the intricacies of going back in time, first let's see why scientists are so confident we can travel into the future.
The faster you move, the slower time ticks for you as others view it relative to the observer. You don't know anything's happening. Your clock still ticks as far, you've still got your heartbeat, all of this. So this is not a physiological thing. It's an actual property of the fabric of space and time under those conditions. So I watch you fly by, and the faster you go, the slower time ticks for you. So not only does speed do this, also the strength of a gravitational field will have the same effect on you. Initially, when formulated, you're thinking it's just because you're moving. It's actually way deeper than that. The GPS satellites orbit higher than our space station. The geosynchronous satellites are like middle orbit. That is far enough away from Earth's source of gravity for them to have a measurably different space-time condition, so that their clocks tick faster than our clocks on Earth's surface. Because they are farther away, their time ticks faster relative to us. But we get precise timings from geosynchronous satellites. How does this work? We pre-correct the time signal from the GPS satellites to compensate for Einstein's general theory of relativity, so that by the time the time reaches us, it's been properly corrected and it matters to us and our space-time continuum, not the one that's in Middle Earth orbit. Once you calculate that, then you do it and say, oh my gosh, the formula works. Einstein was right. It is true.
In physics and relativity, time dilation is the difference in the elapsed time as measured by two clocks. It is either due to a relative velocity between them or to a difference in gravitational potential between their locations. For example, near the vicinity of a black hole. To a distant observer, clocks near a black hole would appear to tick more slowly than those farther away from the black hole. Due to this effect known as gravitational time dilation, an object falling into a black hole is slow as it approaches the event horizon, taking an infinite amount of time to reach it. As we said, besides the difference in gravitational potential, there is another way to travel into the future, and that is going through space in relativistic velocities. As you approach the speed of light, something really strange starts to happen.
Let's keep going faster and faster. 90% the speed of light. 99% the speed of light. Time is ticking slower and slower and slower. For you, you will watch the whole future history of the universe unfold in front of your eyes as fractions of a second go by for you. As you go 99.9, 99.99% the speed of light. There's a formula for this, of course.
Special and general relativity suggest that suitable geometries of space-time, or specific types of motion in space, might allow time travel not only into the future, but also into the past. However, time travel into the past is theoretically possible in certain general relativity space-time geometries, only when travelling faster than the speed of light is permitted. And the problem with going back in time is forgetting about the other side of the coin of the space-time continuum, which is space.
It's not good enough just to travel back in time. You need something to propel you
Yes, I do.
space as well. So it's a space-time machine, not just a time
I tell you what,
because Earth is a moving
it's just going to be me talking from now on. I'm not going to watch any more videos, film any more videos off YouTube, off me telly. It's just going to be me talking. I've got lots of Doctor Who DVDs and Blu-rays. Got a whole menagerie of them. But an interesting person, and there's somebody, there's actually a quite a famous physicist who's actually trying to invent time travel, and his name is Professor Ronald Mallet. And if the subject of time travel is something that takes your fancy, my advice to you is find any of his I've looked for his videos online, and he is actually trying to build a time machine, but the thing that's holding him back with it is funding, really. But has anybody got any opinions on the subject of time travel? Yeah. Have a look at the have a look at any videos done by Professor Ronald Mallet, and he's got his head screwed on. But at the end of the day, whether these are just these I mean the ability to travel through time is just a theory, really. It's just theoretical. I mean, no one's ever been known to have done it. I used to know David H. Boyle, and who ran the Doctor Who and conspiracy theories exhibitions at Blackpool, and he told me on one occasion. I had quite a few conversations with him because he used to buy videos from him, and he actually told me that he travelled through time. He knew how. He said he knew how to do it. He said he travelled millions of years ago and met a dinosaur, and he'd also travelled a little bit forward into the future. There was some way that he told me he'd achieved this, but it was all very complicated. He couldn't pick up what he was saying to me, but he was a bit of an eccentric guy, really. I don't think he was being serious, but anybody's got an interest in time travel, a good thing will be to watch the find videos of Professor Ronald Mallet, because he's the one he's the guy who's trying to invent it. He's had an interest in the possibility of time travel ever since reading the Time Machine by H.G. Wells, which I've got a copy of somewhere. But We'll talk about time travel films. Has anybody seen? Has anybody ever seen Jean-Claude Van Damme, Time Cop, or Back to the Future, or Bill and Ted's Excellent Adventure? Anything like that? Anything in that nature? It could be just a figment of the human imagination, really. It's not necessarily a possibility. It's not necessarily something that will ever happen. But I tell you what, being as there's no one listening to me, I may as well show the rest of this video now.
Target. I just want to make that clear. And by the way, you could still land on Earth, but how is Earth rotated? You could end up in Siberia, in the middle of the ocean, probably, because most of Earth's longitude is spanned by ocean. So it's truth in time travel with regard to these space-time coordinates. Now, we call these your coordinate in space and your coordinate in time. We call that your world line.
Another problem with going back in time using a time machine or a space-time machine is the so-called grandfather.
Your parents from meeting each other. Because then you would have never been born to it is spanned by ocean. So it's truth in time travel with regard to these space-time coordinates. Now, we call these your coordinate in space and your coordinate in time. We call that your world line.
Another problem with going back in time using a time machine or a space-time machine is the so-called grandfather paradox. But what is it exactly?
You cannot go back in time and prevent your parents from meeting each other. Because then you would have never been born to have gone back in time to have prevented your parents from meeting each other. This is the fundamental paradox of time travel. And so, if there were a rule book, that'd be number one rule.
Perhaps the best way to go back in time is to make use of wormholes. The theory of general relativity does suggest a scientific basis for the possibility of backward time travel in certain unusual scenarios. So going through a traversable wormhole could in theory allow you to go back in time.
Find me somebody to love. Amy,
Yeah,
what's that fancy bed for?
what that? That's sleep match. It's analysing their body's unique sleep positions.
What? Shut the side drawer.
I'm serious. It works out exactly what they need for the best night's sleep.
Nah, can't get my head rolled around it.
Then it matches them with the perfect mattress.
It's me. I can feel it in my springs.
Dreams. Let us find you a bed that loves you back.
Yo Valley Organic. Breakfast made with real heart.
Pollen in your way?
And drowsiness. But we've tried Alivia.
Alivia delivers 24 hours.
So we have the sort of the fabric of the space-time continuum. It's not just that space is out there. Space is intricately configured with time. And how do you know this? Space-time are forever conjoined. This fabric can be distorted in such a way that you can change the distance, the space-time distance between two locations. And one way to imagine is imagine all the universe is just on a flat sheet of paper. You're on one edge of the paper, and I want to get to the other edge, and I'll take out light years of time, whatever, however long that takes. I mean, it's light years distance, so I take many years traveling at the speed of light. But if I take the space and warp it, curve it back on itself, Now your location is very close to me. If I could somehow punch through the fabric of space and time and reach your location, something that would otherwise be longer, a shorter distance, and thereby transcending the speed of light. To do so, you're no longer limited by the speed of light. The diameter of our galaxy is 100,000 light years. You can't travel across it unless you figure out a way to warp space and time. So, in that warp, in principle, on paper, you can have a hole that you pass through and just come out the other side. And you're in another place, and if you did it right, you can show up at another time, and that's the most classical invocation of a wormhole.
Another approach for backwards time travel involves a dense spinning cylinder, usually referred to as a Tipler cylinder. Discovered as a solution in general relativity, this hypothetical cylinder is infinitely long and spins fast enough about its long axis, and a spaceship flying around the cylinder on a spiral path could travel back in time, or forward, depending on the direction of its spiral. However, the density and speed required is so great that ordinary matter is not strong enough to construct it.
By the way, if you manage to travel someplace faster than light, you have the capacity to move backwards in time. We've got that one established as well. We just don't have any easy way to travel faster than light. But one way that's been celebrated in science fiction, and you can write it out on paper legitimately, is a wormhole. A wormhole, I'm over here, and I want to get over there, and I want to get there quickly. You can travel through a wormhole that changes the effective distance between where you are and where you're going. And then you sort of look around when you get there, and you find out, oh my gosh, I've traveled 100,000 light years in a matter of a moment. When you do that, you have the capacity to move backwards in time relative to when you left. Now, you don't get to visit yourself. You're in a sort of a different space-time trajectory. So you can't shake hands with yourself before you left. And by the way, there's a huge paradox that people worry about. And many people, including Stephen Hawking, the late Stephen Hawking, worried whether this paradox would prevent backwards time travel completely. Because if you go back in time and prevent your parents from meeting one another, then they wouldn't have ever given birth to you to go back in time to prevent them from meeting one another.
Thanks for watching. Did you like this video? Then show your support by subscribing, ringing the bell, and enabling notifications to never miss videos like this.
It's all very complicated stuff, isn't it? This anyway, anybody who's got an interest in the topic of time travel, my advice is to find any information they can get on Professor Ronald Mallet, because he's actually trying to invent a time machine. So I want to get this up to an hour in length, but it's easier said than done. Whew. He knows, he's got all these theories of how time travel could actually become possible. Well, it's all Greek to me. It's all a bit beyond me. But just in the last few minutes, we're just talking about. This is a discussion on science fiction or time travel. So Does anybody have any favourite science fiction? Is there a particular sci-fi series on TV that that you like to that takes your fans that you find is that you like Star Trek, Doctor Who, anything of that nature. Does anyone remember Sliders? About somebody who finds somebody who has the ability to slide from one parallel universe to another. That was an interesting one. I wonder if you can get what episodes of Sliders are on YouTube. Let's have a look. I tell you what. Just watch. Well, just.
I'm Emeritus Professor of Physics at the University of Surrey.
Well, just watch. Watch this one. This last video. Then we'll call it a day. Then.
My name is Jamal Khalili and I'm Emeritus Professor of Physics at the University of Surrey. My book is called On Time, the Physics that Makes the Universe Count. A question I'm often asked when it comes to the nature of time is whether we can travel through time. After all, if you think about time, according to Einstein, as part of four-dimensional space-time, then I can move through space. I can exist at this point in space or that point in space. I can come back to this point and I can travel around. How is it? Why is it that we can't do the same with time? Why can't we move up and down the time axis? Why are we stuck inexorably moving along the time axis when all time supposedly are there and exist? Well, of course, time isn't exactly like another dimension of space. It is different. It is special. Einstein's theories of relativity may not be the last word on whether or not we can travel through time, but they're the best we have at the moment, and they do tell us something about the possibility of time travel. Of course, we've all watched many movies and TV shows involving time travel. I don't want to go on record actually criticising the really bad time travel movies, Hot Tub Time Machine, but there are also some really intelligent ones. But real physics says when we talk about time travel, we have to make a distinction between the possibility of time travel into the future and time travel back into the past. And it turns out one is easier than the other. Time travel into the future is easy. And I don't just mean if I sit still, tomorrow will eventually arrive, I've time traveled into tomorrow. No, what I mean by time travel into the future is getting there before everyone else. And relativity theory says this is possible by slowing time down. So if I were to head off in a rocket at close to the speed of light and zip around the galaxy for, I don't know, a week, when I come back to Earth, by virtue of traveling very fast, but also, one should say, because I'm accelerating and changing direction, and therefore acceleration being equivalent to gravity means my time is running slower. Essentially, less time will have elapsed for me when I return to Earth than has gone by on Earth without me. So I may have only experienced a few weeks of time travel, but I may return back to Earth years in the future. In a sense, it's not real time travel because it's not that the future was already there waiting for me. I've just sort of fast forwarded to the future. I've moved in along a different timeline, a different world line through space-time, and arrived at the future with less time having gone by for me than for everyone else. But as far as I'm concerned, I could arrive in the future arbitrarily in the distant future, depending on how closely I got to the speed of light, or how strong a gravitational field I felt. So in the film Interstellar, Matthew McConaughey's character is an astronaut, and they land on this water planet that's in orbit around a supermassive black hole. Now, black holes are regions of space where gravity is very, very strong. This planet is in orbit, it's in free fall around the black hole, so they only experience the gravity of the planet itself, but they're nevertheless embedded within the gravitational field of the black hole, where time now is really running slower. That gravity is slowing time so much, the astronauts in the movie know that for every hour they spend on that planet, 7 years are going by on Earth. And sure enough, Matthew McConaughey's character comes back to Earth, having not aged that much, he's not been away that long, but his young daughter's now an old lady. Whether or not you regard that as real time travel is up to you. Much more interesting, of course, is whether we can time travel back into the past. And again, general relativity doesn't rule this out. Theoretically, we can think of such notions, what are called closed time-like curves, which would be the equivalent of riding on a roller coaster and doing a sort of loop-the-loop. As you're traveling along it, your time is unfolding normally. But you loop back in time, you could arrive back at the point in space that you left, but at an earlier moment in time. You can travel back in time that way. The problem, of course, is that this leads to all sorts of paradoxes. So while general relativity strictly doesn't rule out time travel into the past, it leads to all sorts of conundrums which we find rather difficult to get over, such as the famous grandfather paradox. You go back into the past and you're not very nice, so you kill your grandfather before he's met your mother, your grandmother. They never meet, they never marry, your mother's never born, therefore you're never born. And if you're never born, who killed your grandfather? It wasn't you, you have the perfect alibi, you didn't exist, so he doesn't get killed. I've always found that rather strange. Why would you skip a generation? Why not just go back and murder your own mother? Not very nice, I know. But to make it even bleaker, go back and meet your younger self. And then, and kill your younger self. So if you never grow up to be a time-traveling murderer, then you don't get killed. So you do grow up to be a time-traveling murderer, and so on. So there are many such paradoxes that would suggest that time travel into the past is impossible. However, we don't yet know where the loopholes are in our laws of physics that would rule them out. Typically, what many might say is that the only way out of this is to subscribe to potentially an even more fantastical notion, which is that we live in multiple realities.
Claire's bothered about Annie's crisps and garlic meal sandwich. Annie isn't.
The Mediterranean, planned. All this paella for two? Unplanned.
Lavender in Provence, smelling like love, unplanned. Becoming a Greek legend, unplanned.
Discover the magic of the Mediterranean. MSC Cruises. Best holiday ever. Dulcolax. Good morning. Try Dulcolax Liquid. Reactivate your natural...
We've known each other for over 30 years. How old do you think we are? I don't know, like 60.
So there are parallel realities. Certainly there are areas of physics that would suggest this is true. In cosmology, there's the idea of the cosmological multiverse, bubble universes that are formed. In the quantum world, one of the popular ways of explaining the weirdness of the quantum world is to subscribe to what's called the many worlds interpretation. That every time, anywhere in the universe, down at the quantum level, something's faced with a choice, the universe branches into multiple options. Famously, Schrodinger's cat in the box that's dead and alive at the same time, and you open the box to make up its mind because it's made of atoms, and atoms can exist in multiple states. Well, in the many worlds interpretation, there's a you that opens the box to find an alive cat, and there's a you that opens the box to find a dead cat. So these parallel universes exist. This helps us if we're trying to insist on the possibility of time travel into the past. The murdering time traveler can go back in time, but in doing so, they inevitably slip into a parallel reality. In that reality, they can meet and indeed murder their younger self. All that happens is that they will never then grow up in that universe, but the murderer was born and was never murdered in their own universe. So you can have multiple realities. And again, many science fiction writers have written about this, but do we have evidence of parallel realities? Well, no more than we have evidence that time travel into the past is possible. One way many commentators have tried to support the notion that time travel into the past is possible, and to rule out paradox, is the so-called Novikov self-consistency principle. The idea that if you were to travel into the past, then, and you can interact with the past, you can alter things, but you can only make them turn out the way they have turned out. So the example I used many years ago when I was explaining this was the notion that we know 66 million years ago an asteroid hit the Earth and wiped out the dinosaurs, and that allowed mammals to evolve and humans to evolve from them. Had that asteroid not hit the Earth, maybe dinosaurs would still be around today and we wouldn't exist. Well, what if someone in the future invents a time machine and takes some nuclear weapon back in the time machine 66 million years in order to destroy the asteroid so that it doesn't hit the Earth? But when he gets back there, he sees an asteroid actually is much bigger than the one he recalls, and he does his best and fires his nuclear missile at it, fragments it, but a smaller fragment remains that hits the Earth, wipes out the dinosaurs. And so, had he not travelled back in time, something else would have happened. Maybe it would have missed the Earth entirely. So the fact that he travelled back in time caused the past to evolve the way it has into the future. There are problems with this, of course, and people argue it gets rid of paradox. It doesn't, because what if he decides not to go back? What if he gets back to the past and sees that and thinks, oh wow, my nuclear missile isn't going to be able to destroy this, I won't even bother. What if you go back? The one example is a time-traveling scientist. He gets up one day and finds a manual for how to build a time machine in his lab. He uses that manual to build a time machine, and finally when it's built, he gets in the time machine, takes the manual with him, travels back in time and leaves it in the lab for his younger self to find. All perfectly self-consistent. But the problem is, A, where did that manual come from in the first place? This is information, this is knowledge that seems to have been caught in a time loop, ran around forever. And secondly, what if he decides when he builds a time machine not to go back in time, or not to take the manual? He has to do it because that's how he found it. So there's a real assault on free will here. We are forced to do something because the future determines the past. One way that many scientists have got around the idea of the laws of physics allowing time travel into the past is to simply say that it's forbidden for some reason. Stephen Hawking famously said, if time travel into the past is possible, where are all the time travelers from the future? Surely they should be among us today. Well, Stephen Hawking, had his tongue firmly in cheek when he said this, because he knew the answer. Of course, it may be there are no time travelers today simply because, maybe there are, and they're just keeping a low profile. Maybe there aren't because no one wants to come back to 2025. They're waiting for us to sort the planet properly and solve the climate crisis and so on before they organise package tours back into the past. Or it simply could be, the most sensible answer is that there are no time travellers from the future among us today because we haven't built a time machine yet. If you build a time machine, the earliest moment you can use it to travel back to is the moment you turned it on, because that's the moment you hook up that moment in time, and then into the future, you can, at any moment in the future, you can go back to that moment. But you can never go back before the moment because there wasn't a time machine that existed back then. Of course, for now, the idea of time travel into the future and the past is makes for great stories and great movies, but much of science and the technology that we've developed from science today would appear like magic to someone 1,000 years ago or even 100 years ago. So to what extent might we know so much more about the laws of nature 100 or 1,000 years from now and look back to 2025 and say, wow, weren't we naive in thinking that's not possible or that's silly? Maybe in 1,000 years from now we've figured out how to create a wormhole in space that can be used as a time machine. Who knows? One thing is for sure, we should never be so arrogant in thinking that we already have all the answers. We know a lot about the universe, and a lot of what we know we don't think is going to be overthrown for very good reasons. But we don't know everything. So who knows what we might discover in the distant future.
So, I'll end it at this. I've given you all some food for thought, haven't I? With this 3-part discussion that I've done tonight, and so it's. I think that this is a point where it may as well end. I'll be back in 2 or 3 days' time and do another live stream.